Alright, in this video, I'm going to quickly discuss the difference between the words directly, inversely, and jointly proportional. Although I'm probably not going to delve too far into jointly, just because I personally don't ever really see it that much in this class. Let me just make sure I have this. Okay. And this is for when there's going to be problems that are going to say that something is directly proportional to something else or something relating to that. So let's say, for example, what if the question asks y, or the change in y in respect to x is directly proportional, um, wait, let me make sure I'm wording this right. The rate of change in y with respect to x is directly proportional to y. So what this means is that the change in y in respect to x, or dy dx, is directly proportional to y. So it would be y, but there has to be a constant here because you don't know if it's directly proportional doesn't mean that it's just y. You have to put a k there because there's some constant that could exist there. Kind of like how you have a plus c when you're doing antiderivative. There could be a constant here, and so you have to put the k, which, yeah. So now the question is going to ask you to find y. Well, we're going to do the separation of variables we talked about in the last video. And we're going to keep the k over with the dx. So it's going to be 1 over y dy equals k dx. Okay, and then after this, you're going to take the antiderivative both sides, and you're going to get natural log of y. And there's going to be plus c, but we're going to put the plus c over here. And this equals kx, because k is just some number. So when, for example, if it was like 3 dx, and the antiderivative of 3 would be 3x. So the antiderivative of k is just kx. So it would be kx and then plus c. Therefore, y equals e to the kx plus c. Now, but because of algebra, we also know that this is the same thing as saying e to the kx times e to the c, because that's when addition of exponents, you can multiply them. And e to the c is also just going to be some constant, because it's e to some constant. So that's why a lot of times you're going to see it written as this, c e to the kt. And this is one you might want to memorize, that the antiderivative or not antiderivative, but when you're taking a differential equation of y in respect to x and it's directly proportional to y, it's going to be c, capital C, e to the kt. And there will be story problems that I believe we're doing in the next video, which you'll be finding out what c and k are, and then answering questions like that. But that's about that. So that's what directly proportional means. Directly means that it's just being multiplied together. Next one is going to be inversely proportional, and this would be if it's like 1 over y. However, once again, we have to multiply this by a constant, so it would be k over y. So what we're going to do in this situation, multiply the y over, so it would be y dy equals k dx. And take the antiderivative both sides, and you get 1/2 y squared. 1/2 y squared equals kx plus c. Multiply this by 2, and you get y squared equals 2kx plus c. But k can be any constant, so this 2 goes away. And then take the square root, and you get y equals the square root of kx plus c, if it's inversely proportional. Because remember, as we said before, when the c equals 2c equals 10c, they all equal the same thing. And the reason is because c can be any number. So if you take any number and multiply by 2, it's still any number. This isn't like you're solving for an x. Now, it could be if there's a question where they give you information they want you to solve for x, in which case, yes, you do need to make sure. But when you're just finding what the equation is, it really doesn't matter if you have x or 2x or whatever, but you can always just simplify it back to like x. So the last one is jointly, and that's if the two variables are actually being like multiplied together, and you'd get something like this, k, x, y. You'll be using this, but like I rarely hear the words jointly, but would be jointly. If it's like the two variables, the equation and what's being taken in respect to are kind of being multiplied together, that's jointly proportional. And we're going to still do the same method though. It'd be 1 over y dy equals kx dx. Take the antiderivative, and you get the natural log of y. This should be absolute values. I think I forgot the last time. Equals k over 2, but k over 2 is just k, so it'd be kx squared plus c. And it's a similar thing. You just then do e to the kx squared plus c, which equals, sorry, where's the eraser? Which equals c e to the kx squared. Don't memorize this, and don't memorize the inversely one either, just because I was showing you how to do it. But you really need to, probably should memorize, if it's just, sorry, this board is always shaking. Okay, you should probably memorize this one though. And just a quick review, without me saying it, in your head, what is this? I may have written T before. If I wrote T before, I'm sorry. It's just because a lot of times you're doing this in respective time. But this is what you get. I hope that didn't confuse people. So I'm not going to do this again, but I hope it didn't confuse people if I wrote T because I didn't say that. But anyway, yep, that's it.